We're going to switch again. All right, here we go. It turns out that timer 1 has an overflow circuit in it. Everything we did so far, it was based on timer 0. So timer 1 has his own timer 1 overflow. All right? Here's the best part. The best part is that we're going to go through this very quick. Why? Because these two circuits are almost identical. Timer 1 is in fact easier to use than timer 0, right? In engineering, there is no free lunch, which means that when you have something that is easier, that means that there is less options to it. Okay? So here's timer 1. So there is timer 1. Timer 1 is a crystal divided by 4 pre-scale value, but notice you can only divide by 1, 2, 4, and 8. Right? It's just 1, 2, 4, and 8. You do not have more than those 4 options, and your timer is fixed at 16 bits. You can't change that. All right? So here's what I'm going to do. I'm going to go through this fairly quick. Let me know if we're going too fast. This is your equations. 4 times PS divided by FOSC. And this guy is T1C times 2 to the 16 always. It's not 2 to the n anymore. It's 2 to the 16. You see that? Same circuit, same behavior, less options. Does that make sense? Same circuit, same behavior, less options. All right? Here's the calculations. Look how the table changes. This is something that I will ask you to do as homework. These are the 4 options that are available for T1C. The other one has 8 options. This guy has only 4 options. See that? That's it. So 0.2 microseconds, 0.4 microseconds, 0.8 microseconds, 1.6 microseconds. That's all this timer can do at a 20 megahertz crystal. All right? These are the 4 options for T1F. I just want you to redo this work on your own. I just want you to just put it on an Excel spreadsheet and do it. Why? Because once you start doing quizzes on it, it allows you to have a frame of reference, right? If I ask you to create a 0.524 millisecond, 52.4 millisecond overflow, you can actually set it up for 20 megahertz at a prescale of 4 on a timer 1. You can do it. If I ask you to go in between, you can't do it. It cannot be done. I mean, it could be done, but not now. We'll show you how to mess around with the timer later. Does the idea of the table make sense? What is it that we're trying to do is take a look at all possible options that you can get out of the timer. And you have a limited set. There's not much you can do with it. This guy has 4 set points. That's it. The other guy has 8 set points times 2 because you have 2n positions, right? Here is timer 1 controller. I set this up for you so that you can have it already pre-done. You have to add that structure to your header file so you can have these bits in there. So it is already pre-done for you. Make sure you know how to do this. All right, you will see it in the test. Here is the entire data sheet for your reference. This is just for reference. The important part about this one is that there is only 3 instructions that you need to set it up with a FOSC divided by 4 setup. So only 3 instructions are necessary. And these are the instructions. There is a time enable. Turn the timer on. Choose the clock source. This time you have to make it equal to 1. Select the desired prescale value through that circuit. And we're done. All right? Those 3 instructions are the only ones you need to set this guy to work. All right? So let me go back to the data sheet. Let me show you something. There's a data sheet. I want you to notice the following. This circuit is important. That circuit is important, and this circuit is important. So this guy and this guy, these two. This guy here, I want you to look at RD16. This is the enabled register read-write timer in 16-bit operations. This is what I consider an intermediate skill. So we will not be dealing with this right now. This does not make the circuit 8 versus 16-bit counter. It does not do that. This is nothing more than a 16-bit instruction cycle to it or an 8-bit instruction cycle to it. So don't even worry about that circuit. So there is only 3 circuits I care about. Prescale, these two, source select, timer on. All right? That's all you really need to make this guy work. So these are the 3 instructions you need. Timer on, source select, prescale value. See that? That's all you can use. So this is the cookbook. Timer on, source select, PSA equal 1. Here's the code. I'm going really quick through it because it's exactly the same thing as the previous one. I'm going to make you do it just in a minute, all right? All right, here's the code. This is the timer 1 interrupt. See the vector? That's my overflow vector interrupt. How do I turn it on? Now this is different. I want you to pay attention where we're turning these on. Look, timer 0 was on intcon, but timer 1 is in PIE. See? They put it in different spots. So look at your source code. Compared to timer 0, right? You remember how timer 0 was? Let's put them side by side. Yeah. This is the timer 1 setup. This is the timer 0 setup. You see that? Guys, this is a recipe. You just have to watch the recipe. Once you learn the recipe, every time somebody says, oh, set up timer 1 as an interrupt system that will work on overflows, the code will pop up. That's it. All right, so in the slides, you're going to have, that's the timer. So here's the code. Look at the shape of the code. I think that I'm a big stickler for us understanding kind of like patterns.
It says T0 instead of T1.
Where?
Top title.
Oh, yes, let's fix that. Thank you.
For future reference.
Thank you. So look at this. You have interrupt, timer setup, timer interrupt program. That's the exact same shape as the code that we build for timer 0. The exact same code. So the only thing you need to do is replace the setup, the interrupt, and the application goes there. See it? So here's what I want you to do. I want you to take the same program that we build for timer 0. I want you to replicate it in timer 1. Just take this code and plug it into your microprocessor so that timer 1 could do the job, right? That's it. But here's the beauty. I want you to do it without erasing timer 0. After you're done, you're going to have timer 1 going around in one of them, and timer 0 going in a different one. So you could try to do this in timer on pin C1, let's say. And this just is truly copy-paste. It's truly copy-paste. There's nothing special about it. It's just, you just type those lines exactly like that, and you put an output toggle right here in the middle, and the system will just work. Right? So that's what I want you to do. Let's spend some time doing this. So here we go. Let's do this.